So we're going to start talking about complex and imaginary numbers. So this is motivated by this equation here, something like this. X squared plus 4 equals 0. What's the solution to that equation? Maybe we think 2 or negative 2, but we plug those in and we don't get 0, right? But it does seem like there should be some way to express a solution to an equation like this. So we have something called I, which is an imaginary number, which is an interesting way to refer to it. There's nothing especially imaginary about it. It just doesn't exist in the real, it's not a real number, right? It's not on the real number line. And the definition of I is the square root of negative 1. This is the definition of I. So we can look at some properties of I. I squared, if we square both sides, is the square root of negative 1 squared, which is negative 1. And we can use it like this. If we had the square root of a negative number, like negative 25, we can write this as the square root of 25 times the square root of negative 1. And we can use properties of radicals to split that into two radicals, square root of 25 times the square root of negative 1. And we can write this as I. And we can write this as 5. So the answer to this would be 5i. So that's an imaginary number. A complex number is a number that has the form a plus bi. So a is the real part of the complex number, and bi is the imaginary part. So complex number has two parts, a real part and an imaginary part. So if b is 0, right, then this part doesn't exist, and we're just left with a real number. If a is 0 and this part doesn't exist, and we just are left with this, we call this an imaginary number. Okay, so you could write things like 5 plus 2i. 5, the red part, is the real part, and this is the imaginary part. And together, this is a complex number. So you can see that actually the real numbers are a subset of the complex numbers, right? It's if this part is 0, then we're left with real numbers. So complex numbers are bigger than real numbers. Okay, so how do we, if we have an imaginary number and we want to express it in standard form, this is kind of what we did in the last slide. We write the square root of that number, if we have a square root of a negative number, as the square root of a times the square root of negative 1. We write this as I, and then we write it as square root of a times I. So another example, if we had the square root of negative 9, we'd write it as square root of 9 times square root of negative 1. This is 3, this is I, and there we're left with 3i. And this, in standard form, this would be 0 plus 3i. So it is important in standard form for a complex number that the real part goes first and then the complex part. That's just kind of convention, but that's the way that you need to write it in standard form. All right, so if we want to plot a complex number on the complex plane, so here's what the complex plane looks like. The real number line goes along the x-axis, what we normally think of as the x-axis, and the imaginary part goes along what we normally think of as the y-axis. Okay, so if we have a number like negative 2 plus 3i, negative 2 is the real part, so we'd go over to negative 2 along the real axis, and then we go up 3 along the imaginary axis, right? So that there would just be a point on the complex plane that would represent this number 2 plus 3i. All right, so imagine what this would look like. You can draw it on your paper, or just think in your mind. Plot the complex number 3 minus 4i on the complex plane. Well, we go 3 units along the real axis and 4 units down on the imaginary axis, and we would plot our complex number right there. Okay, how do we add and subtract complex numbers? The good news is, just like you'd expect. So if you have one complex number plus another, you add the real parts and you add the imaginary parts, right? So it'd be a plus c plus b plus d times I, right? So you just add the real parts, add the imaginary parts, and subtracting is just the same. This minus this, you'd say a minus c plus b minus d, I. Okay, so what if we had this? Add these two numbers, 3 minus 4i and 2 plus 5i. So we're going to add the real parts, 3 plus 2, and then we will add the imaginary parts, so minus 4 plus 5 times I. And then we just do the addition, 5, 1 is I, right? If plotting and adding and subtracting these seem too easy, that's because you're doing it right. It's just what you'd expect. This isn't really a complicated thing yet.